Hello everyone, I'm Vaishnavi Rajesh and today's session is about classes. This is an overview of the session. Everyone please scan this QR code for, this is for Slido. You can ask your questions there and answer polls. So please make sure you scan this QR code. Okay, so let's start the session. In C++, classes are a fundamental feature of object-oriented programming. So what are classes? Classes are like a blueprint or template which tell us how to define, create, and tell us about the behavior of objects. So a class is a user-defined data type which has its own variables and functions. Variables can be thought of as containers which hold data or information in a program. And functions, they are similar to what we learned in mathematics. They take some input, perform operations, and give an output. They are like a smaller piece of code in a larger program. For example, consider the function add numbers. Suppose they take two integers a and b as input, they return the sum a plus b. So these variables and functions defined inside a class constitute the members of a class. So how do we access these members in a class? We do this by creating something called objects for the class. Objects are the instances of a class, and class is like the blueprint for these objects. Let's see how to write the code for classes. The syntax is pretty simple. We use the keyword class followed by the name of a class. Here we can write anything we want. I have written my class. And to write objects, we write the name of the class, which is same as the name what we have defined over here, followed by the name of an object. And the class definition, the name of the class is followed by curly brackets, and inside it's the body of the class. It has some members, functions, and variables. And at the end, we put a semicolon. A semicolon is very important. Without it, the code won't work. This is an example code. Here I have created a class called my class. This is the body of the class. Then in main, I have created an object called my object for this class I have defined. Coming to the members of a class, as we have discussed earlier, the members are nothing but the variables and functions in a class. These are created and accessed. These are created in the class and can be accessed by objects of a class. The variables are nothing but the data members and functions are the member functions in a class. Here I have a class called room, which has some members in it. Try to guess which of these are data members or the variables and which of these are member functions. As you might have guessed, length, breadth, and height are the data members, and calculate area, calculate volume are the member functions over here. Now let's see a simple analogy to understand classes better. Consider a class called cars. Now you can have different cars with different names, brands, models, etc. But all of them will have certain common properties like having four wheels, a speed limit, a mileage range, etc. So here, car is the class, and these properties are the members of the class. So we can take these properties, speed limit, mileage, to be the data members, and the member functions can be something like applying brakes, increasing the speed, etc. Now coming to access specifiers. In this code, we see this line here, public, This is an access specifier. Access modifiers or specifiers define how a member is accessed in a class. So we can try to access the member of a class from anywhere, from main or from another class or function, but that may not always work because the members can be under some restrictions from access specifiers. So they might not be directly accessible outside the class. In C++, there are three kinds of access specifiers: public, private, and protected. Data members. Data members are variables that hold data associated with each object of the class. They can be of built-in or user-defined data type. It can be int, string, double, array, char, anything. So here is an example of a class, person, and this class has two data members, name, which is a string, and age, which is an integer. The member functions are the functions defined in the class which are used to manipulate the data members of a class. So these, like any normal, their syntax is like normal function. You first write the return type, then the name of the function. This can be anything, and the input parameters. Then within curly braces, the body of the function. The return type, name, and input till here, this is called the declaration of the function. So for member functions, they have to be declared within the class. This along with the body is called definition of the function. These can be defined either outside or inside the class. We'll see an example to understand it better. So over here, the function set dimensions is declared as well as defined within the class. The class ends over here. So we see that there's another member function inside the class called calculate area. This has only been declared inside the class. Its definition lies outside the class. So the syntax for this is also similar to a normal member function, except that we add a few extra terms over here. We first write the return type, then the name of the class, then followed by the symbol, which is called scope resolution operator, and followed by the name of the function, input parameters, and the body. Coming to access specifier. The public access specifier. All class members declared under public will be available to everyone. These can be accessed from anywhere in the code. It can be accessed outside the class, from main, or from other classes and functions as well. The format for accessing them is the name of the object along with this member access specifier, this dot. We'll see an example to understand better. So in this code, we have a class called square. And we just write the word public followed by colon and list data members under it. We have a public data member called side and a public member function called compute area. This compute area function basically just returns the area of the square, which is side into side. Now outside this class in int main, we are creating an object for square called sq1. And in this line, we are accessing the side of the object sq1 by writing sq1.side. This is allowed as by the definition of public data member, it can be accessed anywhere in the code. So we are assigning a value of 2.5 to it and we are printing the side and the area. Let's see what this will give. So as expected, the side is 2.5 and the area is 6.25. Both of them get printed.
Vaishnavi,
Yes.
can you Can you pause for a moment? Like before switching slides, I think people want you to pause.
Okay.
Okay. Sorry to interrupt.
So I'll just show the slide for a while. So remember, the public data members and member functions can be accessible anywhere in the code. Coming to private access specifiers. The class member declared under private cannot be accessed directly outside the code. They can only be accessed by member functions inside the class. So to access these private values, we need to create some functions in public of the class. A small note over here. By default, if we don't mention any access specifiers in a class, all the members will fall under private. Now let's see an example for this. In this code here, we have a class called square, and under public, we have the member function compute area. Now, under private, we have the data member side. This is the scope of the class. This is the body of the class. And outside this, in main, we are creating an object sq1 of the class square. And here we are trying to access the side of object sq1. But side is a private data member. And as we know, it can't be accessed outside the class. But anyway, we are trying to access it and give a value of 2.5 to it. And we are printing side and area to see if this has worked. Let me run the code. So this code gives a compilation error as written over here in line 27 and 29. We are trying to access side, which is a private member, private data member. So this code will not work. It's wrong to write this. Now let's go to the next kind of access specifier, which is protected. Protected and private access specifiers are very similar in the sense that protected also can't be accessed directly outside the class unless with the help of a friend class. But protected can be accessed by a subclass or derived class of that class. A class that inherits the properties of a class is called a subclass. We'll learn more about subclass, derived class, inheritance, friend classes in the following lectures. This is an example. So this is the code. You need to answer this question on Slido as to what will happen when I hit run button. What will the output of the code be? I'll show the code. So let me briefly explain this. Here we have a class named circle, and it has a private data member called radius and a public member function called compute area. This takes an argument r, which is a which is of the data type double, and assigns the value of radius to r, then calculates area by pi r square. And this function itself outputs what the radius and area is. Now outside the class in main, we have created an object for this class. And now we are trying to access this compute area function with an argument for this object. So will this code give compilation error, or will it print the radius and area, whatever we have assigned? I'll wait till more people answer the poll. Guys, please answer the poll. This is the code. Okay, so I'll go ahead with this. Over here, radius and area gets printed. There's no compilation error. Let me explain why. Now, outside the class in int main, for the object, we have only tried to access compute area function. Now, compute area falls under public, so we can access it. It's correct to do so. It takes the input of 1.5, and this function in turn accesses the private data member radius. And by definition of private data member, it can be accessed by member functions of the class. So this is correct. It's allowed. It gets assigned to 1.5 and the area is calculated accordingly and both of them are printed. Now in C++, structures are a way of grouping some related data together. It can have different data types in it like int, double, float, char, anything. So let's look at some key differences between classes and structures. So by default, members of a class are private, but this is not true for all programming languages. Like for Java, it's not. Members of a structure are all public by default. An instance of a class is called an object, whereas the instance of a structure is called a structure variable. Normally, classes are used for data abstraction and inheritance, whereas structures are used for grouping data. As we can see, the syntax for classes and structures are quite similar. This has the keyword of class followed by the name of the class, curly braces, body, and semicolon at the end. Struct has the keyword struct, name of the structure, and the same thing, curly braces, body, and semicolon. In C++, both methods and member functions are almost the same. These terms are often used interchangeably, but there's just a slight difference between them. Member function is a more general term. It refers to any function defined inside a class, regardless of its purpose. But a method is a more specific term. It typically refers to member functions which have the intent of performing certain action associated with the objects of the class. Constructor. A constructor is a special method in a class. It's similar to a member function, but a member function has to be called explicitly to be executed. A constructor gets called automatically when we create an object for the class. The syntax for constructor is just like a normal function, except we don't write a return type for it, and the name of the constructor has to be same as the name of the class which we have defined. Then we write the input parameters and then the body of the constructor. Let's look at this with an example. Over here, we have a class named world. Under public, it has a constructor. Now, constructors are easy to identify. They have the same name as the class name. And this constructor's job is to output these two lines, hello world, and constructor has been called. Now in int main, we create an object 1 of this class world. We do nothing else over here. We just have created the object. Let's run this code. This code has printed hello world, constructor has been called. This means that when the object is created, the constructor is automatically called and it performs the task of printing these two lines. Now let's look at some key features of constructors. Constructor is a member function whose name is the same as the class name. The main function of constructor is generally used to initialize the data members of a class automatically when an object is created. For this, a constructor can take inputs like a normal function after the class name in those parentheses. We'll see an example in the next slide. And constructors do not return any values, so they do not have a return type. So while writing a constructor, we don't write int, void, anything over here before the name like we would for a normal function. Now, in this example, we have a class named car, and under public, we have brand, model, year as the data members, and a constructor car. Here, the constructor has takes two strings and an integer as input and assigns them to brand, model, and year respectively. These brand, model, and year are accessible over here because these data members can be accessed and also they are under public. So in main, we have created an object called car object 1 for this class car. And while creating the object itself, we have to give the input of this format, 2 strings and 1 integer. So here the brand of car object 1 is initialized as BMW, the model to X5, and the year to 1999. Like this, similarly, when we create car object 2, the brand is initialized to Ford, the model to Mustang, and the year to 1969. Here we are trying to output the brand, model, year of object 1 and object 2 just to check that it has been initialized correctly. So yes, the output of this code will be as you expect, will be BMW space X5 space 1999, and similarly for object 2. Now, as we saw in member functions, they have to be declared within the class and can be defined inside or outside. Similarly, constructors also need to be declared inside the class and defined either inside or outside the class. For defining it inside the class, the format is similar to what you would do for a normal function or the constructor in this case, as we saw in the earlier code. We write the constructor name, which is the class name, the input parameters, and the body or the definition of the constructor. For defining it outside the class, we first declare it inside the class, then outside we write the class name followed by the scope resolution operator, very similar to what we saw for uh, member functions. Then we write the name of the constructor, which is basically the class name. And then the list of parameters, the definition or the body of the constructor. Here is a small exercise on constructors. The poll is put up in Slido. Please answer it. The question is, under which access specifier should a constructor be defined so that an object can be created in any function, or the object of the class can be created anywhere and the constructor will be called? Option A, any access specifier will work regardless of where we put it, the constructor will always be called, or constructor should be under private or public or protected. All of you, please participate in the poll. I'll wait for 1 more minute. Okay, as most of you have answered correctly, the answer is option C, public. This is because constructor should be available anywhere in the code. So it's generally defined in public access. Now coming to destructor. Like constructor, destructor is also a special member function in the class. It does the opposite of what a constructor does. Constructor initializes the members of an object. Destructor is used to destroy the object, meaning when an object goes out of scope or its lifetime is over, it's no longer valid, the destructor is automatically called and the object gets destroyed. So a destructor is the last function which will be called before the object gets destroyed. Like constructor and member functions, destructor can also be declared within the class and defined either inside or outside it. Its syntax is almost the same as constructor except for this tilde symbol in the front. So the name of the destructor is also the class name. Then parenthesis, destructor takes no inputs and followed by the body of the destructor. If it's defined outside the class, we write the class name followed by the scope resolution operator, then tilde class name. So this whole thing is the destructor name, parenthesis, then curly braces, and the content of the destructor. Here are some key points about a destructor. It's also a special member function like a constructor. It destroys the class objects that are initialized by the constructor. It also has the same name as class name, preceded by this tilde symbol. One class can only have one destructor. It can't have more than one. Destructor does not take any arguments. This parenthesis is empty. Nor it returns any value. As a constructor is automatically called when you create an object. Destructor is automatically called when the object goes out of scope. The main function of a destructor is to release the memory space which was occupied by the object. A fact about destructor is that it destroys object in the reverse order of creation. That is first constructed, last destructed. Suppose you're creating three objects in the order A, B, C. Destructor will first destroy C, then come to B, then A. So if the object is not created on stack, it's created on heap, the memory using new. The destructor also uses delete to free the memory. Let's see destructors and constructors working with an example. Here we have a class named example. Under public, it has a constructor. The constructor outputs the sentence constructor executed. And in public itself, we have a destructor. Can identify by the tilde symbol over here. This outputs destructor executed. So in int main, we have an example. We have an object for this class example, and the name of the object is 1 and nothing else in main. So let's see what will happen when we run this. So this is the output. First, when the object is created, the constructor is automatically called and it prints the statement constructor executed. Then the object goes out of scope. It's no longer valid or used anymore. The destructor gets called automatically and outputs this destructor executed. So let's see another example for constructors and destructors. Here in this code, we have a class called test. And under public, you have a constructor and a destructor. So there are also two integers in this code called ccount and dcount, which are initially 0. These are essentially used to count how many times the constructor has been called and this how many times the destructor has been called. So inside constructor, every time it's called, it increases ccount by 1. And also we are keeping track of what ccount is. So it's printing the value of ccount. And the destructor, each time it's called, dcount increases by 1. And by printing dcount, we are keeping track of the number of objects destroyed. In main, for the class test, we have created 3 objects, T1, T2, and T3. Now the question here is, which object will be destroyed first? Please answer this poll on Slido. Will it be T1, T2, T3, or this order cannot be determined?
Vaishnavi, can you show the code? Yeah.
Yeah. Everyone, please answer the poll. I'll wait for 2 more minutes. Okay, so as many of you have answered, the answer is T3. Because in properties of destructor, we have learned that objects are destroyed in the reverse order of creation. So here, first object T1 is created, then T2, and T3. So the destruction order will be T3 first, then T2, then T1. Also, let's see what we get when we run this code. So let me explain this output. First, when object T1 is created, the constructor is called and the number of, so C count increases to 1. So the number of objects created is 1, that is T1. Now when we call T2, this C constructor is called C count increases to 2. So the number of objects created become 2. It's referring to T1 and T2. Now when T3 object is created, again the constructor is called C count becomes 3. So now a total of 3 objects T1, T2, T3 has been created. Now when the scope ends, the lifetime of these objects are over. Now the destructor gets called to destroy them. First, for T3, the destructor will get called and T3 gets destroyed. Then for T2, the destructor is called. So number of objects destroyed now are 2. That is T3 and T2 have been destroyed so far. Then for T1, the destructor gets called and T1 also gets destroyed. So the last line is all 3 objects got destroyed. Now here is a small exercise to recap whatever we have done so far. In this program, I have created a class called books and it has some access specifiers and members as you can see. So over here are the list of the members in the class of books and the access specifiers and whether these members are a variable, function, constructor or destructor. So let's quickly map all this. So first under public, we have a data member pages and a member function count pages. So pages, public, member variable. Count pages, again public, member function. Under protected, we have author and print author. So author will come under protected and it's a member variable. Print author, again under protected, it's a member function. Now similarly, again under private, we have publication and revise print. So publication, private, variable, revise print, private, function. Now again under public, we have 2 more functions, books and tilde books. So as we can notice, this has the same name as the class name. So this is a constructor and this is a destructor. So books, public, constructor, tilde books, again public, destructor. Now here 2 more questions are given, which are of true or false form. Please answer this on Slido. Starting with the first question. Are public members accessible from other classes also? Everyone please give the poll. So all these codes which I'm showing on VS are present in the slides. The slides will be shared with you after the session. So as majority of you have answered, it is true. Public members are accessible from anywhere in the code, so they can be accessed from other classes also. Now coming to the next question. A class in C++ can have multiple constructors and destructors. Answer this on Slido. Okay, so let me show the answer to this. The second statement is actually false. A class can have multiple constructors, but it can have only one destructor, as we discussed in the property of destructors. So that's it for today's session. Thank you.
Vaishnavi, can you share the Slido link, the Slido page again?
Okay.
Should I try explaining the link listing now? Vaishnavi, are you done with the session?
Oh, yes.
Yeah, I'll try explaining. Give me a few minutes. Am I better audible now?
Yes.
Yeah, okay, fine, great. So, hi everyone. I think a lot of you had issues with the pre-project, so I'll just briefly go through what's expected and show some pseudocode sort of thing. Uh, can you please post your doubt on chat? Like people have raised their hands. No, I think that's the attendance link. I'll just share my screen. Yeah, so one thing is we are trying to move to Replit. A lot of people had some issue with HackerRank, so we have posted the question on Replit, and we will be sharing the link. The Replit project, as it's called in Replit, is there in the Replit group which we asked you to join at the start of the whole camp. So that's there. Uh, I have also added the same project description. I'll try to explain it one more time. So it is a process scheduler where each process is a structure and they are ordered as a linked list, where the first structure is the first process which is added, and there are three methods which you should implement. Add process, which adds a process to end of the list. Uh, Fork process, which uh, adds a process after the process ID of a given process, and delete process. Uh, I'll show you my brief implementation of all these things. So As we have learned in today's session about classes, you can define your head pointer inside the class like this. Maybe I'll show it here. Or you can define it in the global scope. That's up to you. Also, yeah, that's up to you if you want to define your.
HSN, can you
Yeah,
zoom the code a little bit?
yeah, I'm sorry. Uh, this is fine, right? I
Yeah, yeah,
hope this is fine. Yeah.
yeah, yeah.
You could define the head pointer in the global scope. The head pointer is basically like the theoretical pointer which points to the first node. Initially, it would be null, or you could have it somewhere in the class itself. I prefer to have it in the class. After that, I'll go through my implementations of all the methods, and you can implement something similar. It's up to you. So one thing is the add process method. Uh, what do you need to add a process at the last node? You need the last node, and you just add the process to the last node. So I try to get the last node. How I get the last node, that's up to you. You do have to implement it. I'll just go through the brief idea. Then I create a new process, and based on if the last node is null or so, if there are no nodes, my last node is kind of is null. In which case, my head becomes the process which is being added. In case the last node is not null, which is like there are already nodes in it, I just append the new process to the last node. That's the brief idea of the add process method. Uh, so let's write it down. Find the last node. If there are no nodes, head becomes the new process to be appended. The last process, I'm sorry. And if there is a last node, add your process to it. That's kind of the whole idea. Delete process. What do I need for deleting a process? So I'll show it in the diagram. So over here, when we are deleting the process, here we are deleting process 2. So basically, my idea is to get process 1 and change its next process pointer to the process after process 2. One thing which I'm doing is I'm not really caring about the previous process methods, previous process pointers, because I'm not using them anywhere. That's up to you. If you want to care about previous process pointers, I feel that will make your implementation a bit more complex, but you're free to do it or not do it. I prefer not doing it over here. Or delete process. I need the previous process basically, and I need to change the next process of the previous process. That's the main idea. So that's what I'm going to do. I get the previous process. The previous process is null, in which case the head process is the one which I'm going to delete. In that case, the new head becomes the one after the head process. Uh, New process after the head process. And if the previous process is not null, that is the process I want to delete is like a non-head thing. Somewhere it's like the second process, third process, or somewhere, something like that. In that case, I change the process after the. So if uh, P1 is the process to be deleted, the previous process's next process will be P1's next process. I hope you get the idea. Uh, and then for fork, basically I get the process. I added the next process after the fork process. I add a process after the fork process, the new process. And a process after a new process should be two processes after the fourth process. I'll just explain it over here. So yeah, so 99 is the process which I want to add after process 2. So what do? I change the next pointer of process 2 to 99. And I also change the next process pointer of process 99 to process 3. I have to make two changes, which is basically what I'm doing here. So that's my idea of implementing these three methods. I will send these write-ups. We won't be sharing the code, but I will send the brief write-ups of how I would do add process, delete process, and fork. If you have any doubts, you can ask now. I'll be in the meet for about 10 to 15 minutes. Attendance was the rating sheet. That's it. We'll also be sharing the Replit link for submissions after this. We are moving from HackerRank to Replit. If you have submitted in HackerRank already, please submit again in Replit. If you have any questions, please ask. If you have raised your hand, please post your doubt either over here on or on Slido. We'll share the Replit link. It's ready. It's ready over here. We'll share it afterwards. Will there be any more contests? There are 2 mini projects and 1 final project. So next mini project will be released on this Friday, and the final project will be after the last session. The deadline for this mini project is 1 week from today. So today's 11th, I assume. So yeah. So the deadline for the next mini project would be 18th. So this mini project is 18th, and for the next mini project it would be 24th. Where is it? Where is what? What is a process? Okay, so here we have a concept of a process which we are trying to schedule. Each process is basically a structure which is like a node in a linked list. Please try to read up on what a linked list is. We have attached references in the questionnaire. I'll also put out these references over here. Okay. Okay, I can't copy them right now, so I'll put it out in the group. That's a process is basically a structure. It's a node in a linked list. We are giving it a fancy name. That's all we are doing. Yeah, it's a node in a linked list. Can you explain a bit? Like it would be better if you're more specific. Can we leave if you have submitted process? Yeah. Attendance is marked. You can leave. I'll be in the meet for some 10 minutes, some 10 or so minutes. You can ask doubts. I'll be checking Slido and Teamstat. I'll be in the meet till 8:20. After that, we'll end the meet. So till then, you can ask any doubts. Farul, can you just post the Replit link in the groups? Should I learn the theory behind and from where, or more? Or I would suggest you go through what a linked list is and how it's implemented in C or C++. The links do a great job at it, is what I believe. Uh, and that's most of the theory apart from what we have covered. Like, it's the extra theory you would need apart from what we have covered in the sessions. What a linked list is, that's all you would have to go through. Uh, is there any other theory in specific you're trying to point out? Uh, the conclave, which I assume is the CP session, is different from us. So I would suggest you ask in the group. DQs, heaps, real-time implementation. We don't plan to teach heaps and DQs in this camp. For the other CP camp, you would have to check with them. I do think their last session is briefly explaining about STL sets and some data structures, but I would check with the other camp. We mostly are going to focus on object-oriented programming for the next couple of sessions, and after that, it would be a bit of uh, file handling and streams, and then the internal implementation of the STL library, like a brief idea about it. That's it. We might have our future mini projects might have some implementation of DQs or heaps though, but I'm not sure about it yet. Yeah, are there any other aspects of code CPI? I think this camp is aimed to explore about what programming is apart from CPV. CP is problem solving. It is a good chunk of coding, but you aren't always going to be writing 100 lines of code or like 20 lines of code, whatever your question takes to solve a problem. Sometimes sometimes you have to integrate your code into larger code bases. Not sometimes, but all the time if you're going to work with code. And I think some of the concepts which this camp tries to talk about are oriented more towards that, like the practical aspects of coding. How can what are the other skills you would need along with problem solving to use coding to create solutions? And this camp to some extent discusses about how to create a product. Perfect. Where can I access the after each session? So you can find them in the group, I believe. Uh, can some coordinator post in the chat? I hope we are sharing the slides for all the sessions.
Yes, it is in the info doc, and the info doc has been shared in the group.
It's in the description also, right? Like group description.
Yeah.
Okay. So you can check the group description for the info doc. Okay, great. I think we will be ending the meet now. Yeah. Thanks, everyone. You can stop recording. I think we can stop recording now.